Okay. Polar example 13. It says find the area inside both the circle r equals cosine theta. Let's begin by drawing my circle. It's a cosine oriented on the x-axis with a radius of 1. So there's r equals cosine theta. Cosine. R equals cosine theta. And the rose curve, r equals sine of 2 theta. Well, it's a rose. N is even. If it's even, it has twice the number of petals, so it has 4 petals. It's a sine. If you're not sure what it looks like, you can do a few theta r values. I'm starting at 0. At 0, sine of 0 is 0, so it's going to be here. And then I'm going to go ahead and grab a couple of extra values if I'm not sure. Pi over 4, 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. So at pi over 4, here, it's 1. Let's just say right about there. So it's going to come out, and it's going to make 1. I am horrible at drawing these. Wow, that's really bad. It looks like this. Okay. It looks something like that. If you're not sure, you can sketch it on your calculator to check yourself. And what I'm wanting is it's the area inside both the circle and the rose curve. So I want this and this. Okay, so there's 2 of them. I can either find the area of one of them and double it, or I can split it up and find the area of this one and then the area of this one. I need to find these points. I need to find out where they intersect, because that will give me my limits of integration. So to set them equal, I set cosine of theta equals sine of 2 theta. Whoops, 2 theta. And if you think back to pre-calculus, in order to solve this, I can't deal with this 2 theta. I have to get rid of that. And if you recall your trig identities, wonder how well we remember those. Sine of 2 theta is the same as 2 sine theta cosine theta. We do need to look at those double angle identities and make sure we have those committed to memory. So I'm going to set this thing equal to 0. So I'm just going to move my cosine over. My equal to 0 is over here, but I don't like writing it over there. 2 sine of theta cosine of theta minus cosine of theta equals 0. I just moved my equal 0 over to the other side. I can factor out a cosine. So it would be 2 sine of theta minus 1. 0 product property says I can set them both equal to 0. Hold on. Sorry about that little delay that you probably didn't know occurred. I had somebody come in my room. So I paused it. Cosine of theta equals 0, and 2 sine of theta minus 1 equals 0. So add 1 divided by 2. Sine of theta equals 1/2. So now I'm like, okay, where is cosine 0? Well, cosine is 0 at pi over 2. And then I would have to, at 3 pi over 2, but that's down here. I don't need that part. And then where is sine 1/2? Well, sine is 1/2 at pi over 6. And if you look at where these are, what quadrants these intersections are, here's pi over 6. Here is negative pi over 6. So, and negative pi over 6. So what I need is, if you look at it, this actually has 2 separate little pieces. If you think about your little windshield wiper going around, it's going to here, and right there, it splits. Okay? So what I need to do is I need to do 1/2 the integral from 0 to where it splits. It splits at pi over 6. Of which one is it hitting from all the way around right there? Well, it's hitting the pink graph. The pink graph is my sine of 2 theta. Okay? Plus, from pi over 6 back to 0, which is pi over 2, I'm on my cosine graph. Now I'm on my circle. Okay, so from 1/2 pi over 6 back to 0, which is pi over 2, of the circle graph. Because if you just kind of look at it, you're going your radius. It's always about your radius. What is your radius? Which graph is your radius hitting? Well, on this side, it's like a leaf. It was hitting the rose graph, and on this side, it's hitting the circle. You're going to do your circle, which is your cosine of theta squared d theta. Now, this expression is going to give you the area of this piece. Well, if these are the same, because it's symmetric, and they are, I can just multiply that whole thing by 2. I'm not going to take the time to stick these in the calculator. The hardest part of this is figuring out the limits of integration and your setup. So that's the only part I'm going to focus on. Go ahead and stick that in your calculator and see what you get, and you can check yourself tomorrow when you get to class.